Zoom and share my screen, and we'll come over here. And we've got Python Tutor opened up with all of the problems. So again, like all the previous quizzes, you'll be grading it yourself, and we'll be going over the problems in class here. And again, the purpose of this is so that you both get the immediate feedback on how you're doing, and you get to ask questions if you have questions about why your solution was different, or just why the solution is the way it is. Because I have all these solutions opened up here in Python Tutor, you should be double checking to make sure that whatever the code is that's on the piece of paper in front of you matches the code that I have up here, that I didn't make some sort of mistake somewhere. Because if I made a mistake, then everybody will get it wrong, and that'll be bad. Okay, so I believe this is problem number 1. And here to make things a little bit computationally in your brain a little bit simpler for you all, use smaller lists than in the practice packets. But so here is our list right here. When I press the next button, it's going to create that actual list object over here. Everything in yellow, now the list object. This XS variable contains this sort of pointer over to this list object. And now really this is the hard part of the problem here, XS at -5:. Again, with the negative numbers, you start from the right and count backwards. So this is -1, -2, -3, -4, -5. So this is going to be the start of my new list at position 1 right here, containing the value 3. And I have a colon with nothing after it, which means I'm going to go all the way from this position to the very end. So I press next right here, and now YS contains everything starting at the 3 right here up to and including the 11. So 3, 5, 7, 9, 11. And now under total right here, I'm computing the length of the list YS. So the last element is a 4 over here, but the length is not 4 because we start counting at 0. So it's 4 plus 1 is 5. Length is 5, so total is equal to 5. Print that out, and total equals 5 is the correct answer for number 1. Any questions on the first problem? Okay, again, what this was intending to test was your ability to do slices right here. On to problem number 2. So now we have the same list, but now a for loop somehow going over some sort of elements in the list. Press next, we get the same list object over here. Total starts off at 0. And now we have our for loop. So the first thing this is testing is this range right here. What are the values that we're going to get out of this range? So we always start at the very first thing over here at the 1. So the I will start at the value of 1. Now we do total plus equals XS at position I, or XS square bracket I, or XS of I, or just XSI. And here, so I is equal to 1. So I'm going to find the 1 position over here. This is the 1 position. It has value 3. So this XS at position 1 will give me the value 3. I'll do total plus equals 3. Total starts at 0. 0 plus 3 is 3. And total takes 3. Now we're on to the second iteration of the for loop, and this is potentially where things get tricky. At the previous iteration, our I value is 1. When we have 3 values here inside the range function, then this last value over here is the step size. It's the amount that we add onto I each time to get the next I. 1 plus 2 is going to be 3, so my next I value right here is 3. Skipped over 2. Now we do the XS at position I now containing 3, XS at position I up here on the top. These are the indexes, these are the positions. And so we get the value of 7. XS at I on this iteration of the for loop is equal to 7. We do total plus equals 7. Total starts as 3. 3 plus 7 is 10. Press next, and total takes 10. Back up here to the for loop, starting, or I is equal to 3. 3 plus 2 is 5, but the range here ends at position 5. We always go up 2, but not including this number right here. So our I would be 5 if we added 2 to it, but that's too big, so we don't go into the for loop anymore. Skip down over here to print total, and we get that total equals 10 for the final answer. So this one was integrating a lot of different knowledge about the range function here and how the indexing right here works. And any questions about any of that? Okay, problem number 3. Okay, a tiny little list, just 2 elements inside of it, XS 1 and 3 over here. Total starting off equals 0, and now we have we have just 1 for loop, but it's the different kind of for loop where we're looping over the values instead of looping over the range function for X in XS. Anytime you see a list over here to the right of the in, then we're going to be looping over the values of that list. And the common pattern that you'll see is you'll see something plural to the right of in, and you'll see something singular to the left over here. So again, lists not required in Python, but all good Pythonistas, all good Python programmers do this. They make your lists plural because they contain multiple things. And you make your things that are not lists singular because it's only one thing. And so this is, you'll see for loops like this everywhere in Python for something in some things, for X in XS. Press next here. So X starts at 1. It doesn't start at 0. It starts at 1 because the very first value in this list is 1. The very first index is 0, but the first value is 1. So X equals 1. We do 1 times 2. That's equal to 2. Total plus equals 2 gives me 2. There we go. Back up here to this for loop. The previous one we did X equals 1. Now we're on to 3 as our next value. So 3 will be the next value of X. Recompute this. 3 times 2 is 6. Add that to total. 2 plus 6 is 8. There we go. Total is equal to 8. And now there's nothing left in this list over here. So we will not go into the for loop anymore. We'll jump down here and print total equals 8 for number 3. Any questions on problem number 3? Problem number 4. Now we get nested for loops here. Both styles of for loops happening at once, XS and total. Just initializing the problem again. Same list up here, total starting off at 0 like usual. For X in XS. So again, this for loop right here will be looping over the values of XS. Press next. The very first value in XS is X equal to 1, right here, the very first value. And now we have another for loop for I in range 2. Range 2 is going to start at 0 and then go to 1, up to not including 2. So the very first time I will be equal to 0. And we have X plus I right here, 1 plus 0. Store that in the Y variable, 1 right here. And then total plus equals Y, total plus equals 1 right there. Press next, and there we go, the total at 1. And it's very important after we run this line right here that we go back to this for loop right here. You always, when you're inside of these nested for loops, you do these inner for loops as many times as you have to before going back up to this outer for loop. So we're not going to change the X value. The X value is going to stay at 1. It's going to stay as this first element in this list right here. And then the I value is going to change because I'm back on line 4, not on line 3, I'm on line 4. And so for I in range 2, well, I was currently 0. So the next value in this range 2 is going to be 1. Press next. Now I did 2 lines right there at once. It did the Y equals X plus I, 2. X is 1, I is 1, gives me 2, stores the 2 into the Y. Now we have the total plus equals Y. Total right here, 1 plus equals 2 will give me 3. Press next. And we go back up to this for loop line again. And now it's going to ask, okay, I is at position or has value 1. Is there anything left in this range? And the answer is no. We've already done the 0. We've already done the 1. If we did 2 next, that would be too big. So we're not going to repeat the body of this for loop right now. We're going to go to the very end. The very end of it is the end of this for loop body right here. So we're going to actually jump up to this line right here now that we've completed everything in this inner for loop. Current value of X is equal to 1. The very next value of X in the list is going to be equal to 3. So I press next. X now takes the value of 3, and now we're back inside at this for loop again. So we're going to run this inner for loop for every one of these values. Run it for every one of those values. And so I is going to Once again, take the 0 value because that's the very beginning of range. And now y equals x plus I. 3 plus 0 is 3. So y takes the value 3, total plus equals 3. Now total's sitting at 6. For I in range 2 again, I is currently at 0, so it's going to go up to 1. I is at 1. Y equals x plus I. 3 plus 1 is 4. Y takes 4. Total plus equals y. Total's at 6. Plus 4 is going to get me 10. Press next. Finished with this for loop right here because we've done all the i's. Press next. Come back up to this for loop right here. We're finished with this for loop because we've done all the x's. Press next. Coming down here, print total equals total, and we have that total equals 10 for problem number 4. Whew. That was a big one. Very easy on these nested sort of for loops to just get caught up in forgetting where exactly you are in the computation if you've done the for loops just one time or multiple times. But the key thing that you definitely have to remember, that's definitely going to come up over and over and over again in this class, is that the inner for loop happens once for every time the outer for loop happens. It's just going to happen over and over and over again. It's going to happen a lot of times. Any questions on problem number 4? Okay, problem number 5. Here we have the list of lists, nested lists. So again, anytime we have things that are lists, I like to make them plural. So this is a list of lists. So it's a double plural. Those don't exist in English, but they should. So we have XSS right here. And our total will start at 0. Over here on the right-hand side with this XSS, there's all these list objects down here. This outer sort of list object doesn't actually contain any numbers inside of it. Instead, it contains these sort of pointer things to other lists. And so when we do these indexing things right here, I have to, if I have XSS at 2, here is this list right here is my XSS list. Go to position 2. And this part right here, XSS at position 2, points me down to this list right here. So this is the list that I'm looking at. That list corresponds to this section right here. This bottom right list down here corresponds to XSS at 2. And now I have the -1 that I'm indexing into this list right over here. So negative starting from the right-hand side. And that's going to be this position 5 over here, which also has value 5. So this right here is going to take value 5, and we'll add that to total, which is currently 0, plus 5 will give me 5. Once again, XSS at position -1. So this is the outer list that I'm looking at, XSS at position -1. -1 is the very last entry in this list, also corresponds to this 2 entry in this list. So once again, we're looking at this same last list down over here. This XSS at -1 happens to be equal to XSS at position 2 in this case. And since it also contains the -1 to the right-hand side, we're still looking at the very rightmost position over here, this 5 value. And so when I press next, we're going to add 5 onto total again, and boom, total equals 10. Now we have XSS at position -3. So starting from the right over here in this XSS list, this is the position -1, -2, -3. We're looking at this list over here now, this top rightmost list. This XSS at position -3 corresponds to this list right over here. And then we're looking at position number 2 inside of this list. Here's index number 2. Here's another 5. So we're going to do, this whole thing is going to evaluate to 5. Add that onto total, and total is 15. Total equals 15 is the answer. Any questions on problem number 5 here? Any questions on anything related to the quiz? Okay, then go ahead and total your score up on the front and somehow get your quizzes up to me. Okay, are there any other quizzes that I don't have yet? Okay. Yeah, so let's do a quick overview of what we're going to be covering today. Over here in the topic 4, again, we're on week 4, not week 5. Those muggles think that 1 is the first number, but we know that 0 is the first number. And so we're in our topic 4 on Python text. We will probably get to this notes.py file today. So if you want to follow along going through that, then you should download that file. And again, if you're downloading a file in GitHub, you don't want to copy and paste. That will probably screw things up in Python, because Python really cares about white space, and your web browser probably does not. And so to download things, you right-click on this raw button and go to the save link as, and that will download the file for you. In class today, yeah, so we'll get to this possibly by the end of class, but we'll also be talking about, so over here back on the topic 4 Python text, I've posted a lab for us. It's a little bit different than the last 2 labs, so we'll talk about this in detail today, what you're supposed to do for it. And there's also a project. Your next project has been posted. We'll talk about exactly what that's going to look like today in class as well. And this notes.py, this file right here. The reason we're going over this is because this is going to be like how you solve the project 1. We'll be implementing part of that project in class. Any questions on the setup before we get started with the contents? Okay. So the idea, we'll start with the project, going over the project. The idea of this project, refresh this, is you're going to be implementing something called a Markdown to HTML compiler. So in Python, again, these first 3 weeks of Python, we've been doing sort of a lot of puzzles, not a whole lot of necessarily application-ish things. This is going to be our first, I think, interesting application. It's not quite yet into like the humanities-ish, like really cool things, but this is a cool technical thing that we'll be getting to. And just like these first 3 weeks of Python has been, I think, potentially very difficult just because there's a lot of new material, I think this is the hardest project that we're going to have this semester. Just because, again, it's the really understanding for loops and strings and how all this stuff works together is the hard part of this project and the hard part of all the other projects. So if you can do this project, then the other projects are going to be much, much simpler. But note that this project will be significantly more difficult than the first project in this class. And I have this little picture here to just emphasize again that no matter like how good of a programmer you are, how professional of a programmer you are, whether you're getting paid nothing or you're getting paid hundreds of thousands of dollars at Google, you're always like cursing your code. Like, so bad code has a lot of WTFs per minute, but even like good code, great code, people are still cursing at it. Like, what is going on here? So if you curse at your computer while you're doing this project, then you are in good company. Okay, the idea of this project is that HTML, the very first project, we were writing HTML by hand, but this is basically never done at all these days. Instead, we write programs like Python programs that are going to create HTML for us automatically somehow. And the idea of this homework is we're going to write a Python program that will generate HTML from something called Markdown. Markdown is a language that's much simpler than HTML, and so because of that, it's very, very widely used. pretty much every social media website except Facebook supports Markdown in some form. So Reddit is the most popular one that has lots and lots of Markdown support, has sort of full Markdown support, but everything else for the most part has some support for it. If you take, so a good follow-up class to this is the Fundamentals of Data Science CS36 course. If you take that class, then all of your homeworks will be completed in something called R Markdown. If you've already taken that class, then you're a little bit familiar with Markdown already. The vast majority of blogs on the internet, so like my own, or any blog that is written in like WordPress software, use Markdown internally to format all of the posts that people write. And GitHub itself has, it's called GitHub flavored Markdown. And all of these files in our class, all of these instructions that we're looking at have been written in Markdown and then somehow converted to HTML. So we're going to take a look at what that looks like from GitHub's perspective in the lab. We're going to jump over to the lab here, and then we're going to come back to the project here. So up here, I have the lab open. And in part one of this lab, the purpose of this part one lab is to get us somewhat familiar with Markdown and the syntax of Markdown, and so that you can actually convert that into HTML. There's this issue 257. I just posted it while you all were taking the quiz. And if we click that, here we go. It has the instructions on what you're supposed to do with Markdown right here. The basic idea is that everybody has to reply to this post with a whole bunch of Markdown formatted things. And you can see that up here, I have a bunch of different examples. And I'm going to make a reply right here that has some more examples, and we'll go through like what that actually looks like. So right down here, I'll say this is my reply. And then there's this preview button over here. If you do that, we can see there's no special formatting on this is my reply, because it's just text, no code at all. And I'll say this is ** bold ** like this. So in HTML, if I wanted to make something bold, in HTML, we did something like B bold like that. In Markdown, we use this ** instead of the B. And when I press the preview over here, you can see that it actually makes both the Markdown over here bold and the HTML over here bold. If I right click on this bold right here, this is the one that we created with Markdown. I'll right click on that, go to inspect. Let all this open up. And you can see that it's using the strong tag to make this text right here bold. That the internally GitHub for its issues has this Markdown compiler. A compiler is something that converts between programming languages. And the Markdown compiler converted this ** right here into a bold HTML tag. Yes?
Could you write in your code like strong and not strong, or that?
Yeah, and so over here, I use the B tag, B standing for bold. B and strong are 100% equivalent to each other. And so I could do that, and it would also allow that HTML to go through. Any HTML that corresponds directly to a Markdown tag, it's going to allow you to use that HTML. So besides bold, there's this is * italic. If you just have a single star on each side, then it's italic like that. Italic. We right click on that and go to inspect. Here we go. We can see that it's using the em tag in this case for italic. And it's just the key thing here is that it's converting this star somehow into this HTML tag so that so that we can visually see it nicely inside of Firefox. In this case, the stars, I mean, to me, this looks a lot more readable than this HTML tag right here, but it's not like too much more readable. One of the things that's really nice here is that like paragraphs are going to be automatically added for me, these sort of block level elements. Remember that these are inline elements, italic, bold inline elements block level elements like this. This is a new paragraph, and this is another paragraph like that. I can just write my paragraphs like I would normally write paragraphs, so that it actually looks like I can just read it and, oh yeah, this is obviously a new paragraph right here. And when I preview this, then it's going to automatically add the appropriate tags so that those get displayed as new paragraphs. I right-clicked right here, and you can see that now there's these 3 P tags, this P tag here, this one here, and this one here, each corresponding to these different paragraphs. So again, the Markdown compiler internally somehow recognized that this, there's a blank line here, so it should be a new paragraph, and created the new paragraph. If I don't have a blank line like this, go over to preview, you can see that that's not actually going to be creating a new paragraph there, because they're right next to each other. One of the things that is really, really useful in Markdown is what are called code blocks. So if I do for I in range 10, print I, so like this is Python code right here. If I have it inside of these are triple back quotes. So there's 3 types of quotation marks on your keyboard. There's the single normal quote, there's the double normal quote, and then on a US keyboard in the top left, just under the escape key, there's the back tick or the back quotation mark. These are back ticks, back quotation marks. And if I press preview over here, then it gives me this sort of nice formatting saying, hey, this is all like inside of code, and it doesn't try to do like weird formatting stuff. If you didn't have these backticks, then it might mangle this formatting somehow. This is, yes, question. Question is, will it automatically tab the print I? And the answer is no, that GitHub issues is not like VS Code where it's intended for people to be like writing long things of code inside of here. This would normally be something that like you would write it somewhere else and copy and paste it into GitHub issues.
Why that code block around? I mean, in this case, mine was the same, but sometimes we say ruin it.
Yeah, so if we took that away, you'd see that like this space over here before the print, it's not including it because it doesn't think that's important from Markdown's perspective, but from like a code perspective, those spaces are super important. And so in this case, we could probably guess, oh yeah, that print I is probably inside this for loop right here. But then if we also had like a print 10 right here, I don't know, is this print 10 inside the for loop or is it not? I don't know. But if I add these triple back quotes like that, then it's obvious that this print 10 is now not inside the for loop. This is called, again, the block code element. There is an inline code element, like this is how you reference the single back tick like this print function. And these inline code blocks are intended for if you have just like, yeah, small piece of code, doesn't need multiple lines, but you still care about like making sure that people realize that this is in fact code right here, and the whole thing by itself is important. There's a lot of different functionality inside of Markdown, but again, the basic idea is that with all of these things, let's right-click here, inspect on this big code block right here. And we can see that it's using this pre-HTML tag. Pre stands for pre-formatted. It's the standard HTML tag for code. And Markdown, the Markdown compiler inside of GitHub is converting all of these Markdown style elements into HTML for us. The actual lab has a bunch of different things that you're required to do. And if you click on this link right here that I give you, it has the full like syntax guide of how to do things inside of Markdown. And so the expectation for the lab is that, for example, So I've already told you how to do bold text and italics text. I haven't told you how to do this strike through text, but the expectation is that you'll be able to look through this documentation right here, do a search, Control F, strike through, and then, oh, here we get some examples of how to do strike through text, and you can do that, add that into the comment that you're required to create right here. And so by doing all this, you'll get familiar with all the different types of Markdown syntax that you'll be using in your own compiler that you'll be creating. All great questions that we've had so far. Any other questions just on what Markdown is?
Or when we want to indent for code, we'll just use the space bar to do that.
The question is, if you're writing code inside of Firefox, inside of one of these windows right here, and if you press tab, you'll notice that it doesn't actually like add a tab at all. Instead, in Firefox or Chrome or Safari, every web browser, what tab does is it cycles through all the buttons on the web page. It's intended for people who, for example, do not have a mouse, possibly because they are just on a really old computer, or possibly because they're disabled and for whatever reason they can't actually use a mouse. So people, for example, with cerebral palsy can't actually like manipulate a mouse, but they can type on special keyboards. And in order for somebody with cerebral palsy to browse the web, they have to be able to press the tab button to go between things. And so that's why on web browsers, tab does not actually add spaces, but adds it switches between elements on the screen. So yes, the tab key doesn't do what you expect. It you'd have to use spaces. Good question. Any other questions on Markdown or GitHub issues? Okay, I'll go ahead and just post this comment right here. Your replies will have to have more things inside of it, but this is just a short example. And now let's head back over to our project. Where did that go? Here we go. So we've talked about the description now. We've talked about what Markdown is, and we know that inside GitHub, they somehow have some utility, which is converting Markdown into HTML. We've just seen how it works, or we've seen the results of it on the GitHub issues, but it's actually used internally all over GitHub. There's Markdown all over the place in GitHub, and it's used all over the place. And so somebody at GitHub, working at GitHub, implemented this functionality. And so I want to do a little aside here about how much GitHub paid for this functionality and how much a junior developer made implementing this at GitHub. So first, how much did it cost to GitHub to implement this functionality? If I were like the CTO, Chief Technology Officer at GitHub, well, it's in its startup phases, I would have assigned this functionality to like an entry-level engineer, somebody straight out of college, and I would expect it to take them maybe 1 week or so of work. At GitHub, entry-level engineers make, there's a little bit out of date, last year it was $148,000 per year. If we come over, if you click this link right here, it'll take you over to this web page, which has salaries for GitHub. The current salary for entry-level engineers is $139,000 per year. The reason it went down is because of part of that salary is paid in stock options, and GitHub is owned by Microsoft. And if we look at Microsoft Corporation over the last year, the stock has just gone down a little bit for whatever reason. And so the salary is still pretty good, starting at, used to be $148,000 per year because of the stock. Now it's $130 something per year. But either way, it's still about $3,000 per week that GitHub is paying somebody. It actually costs GitHub, due to various HR reasons, about $6,000 per week for like their insurance and various tax things that they have to do. But from your perspective, like from the programmer's perspective, they got $3,000 basically to implement this feature. So you're implementing something that somebody got paid $3,000 to implement at GitHub. And so now the question is like, was this a good investment by GitHub? If you look at the number of users that GitHub has 60 million active users, a little bit more than that. So GitHub spent something like 0.005 cents per user on this feature. And it was a one-time fee. after this was done, people get to use it forever. And GitHub makes on average about $4 per user per month. If you click this link, it'll tell you that. So this is like absolutely nothing in the grand scheme of how much GitHub makes per user. That's the reason why programmer salaries are so high, is because websites have so many users that like GitHub doesn't even notice missing 3,000 per week compared to how much they're making from their users. If this sort of like analysis is interesting to you, like how to divide up software projects, how much different things cost, and how much people get paid because of that, this sort of doing this is called software engineering. And we don't at CMC offer a software engineering class, but if you wanted to, MUD and Pomona offer software engineering classes that talk about this stuff. Questions about any of that, Jackson?
What is time? I mean, like,
Question is here, what is compute time? So here I said they make about $4 per user per month selling compute time. This would be like cloud computing resources that if you had a really big project that you were trying to run, then you might not want to do it just on your own laptop because it might take a really long time. And so you can use GitHub's computers to do that, and it'll go much faster. In the follow-on class to this class, CS46, data structures, we talk a lot about sort of cloud computing, how to take advantage of cloud computing. And we also talk about like, so here we have like these test suites that we've been using for the labs and this project, how to automate all of that. GitHub can guarantee, like by running things automatically in the background while you're sleeping, guarantee that there's no bugs in your code. So that's like their main service is selling that cloud computing, and they offer free sort of things like we're using in this class to try to get people to pay money for their services, to get them in the door. Good question. Any other questions so far? Okay, due date for this assignment. By the end of today, we'll have talked about everything you need for the assignment. So my recommendation is to try to complete it by this coming Sunday, because we will be talking about new material, new things. You'll have new assignments next week. But you have about 10 days from now until next Sunday to complete it, if you, for whatever reason, would like that extra time. And again, this is by far the biggest, most complicated project that we've had so far. So don't put it off until the last minute, or you will very likely run out of time. Things that we're going to be testing here. So again, learning a new programming language, Markdown. After this, you'll know a little bit of Python, all of Markdown, and HTML and CSS. The main thing that we're going to be taking advantage of this in, or the main techniques you'll need, is string manipulation. So all the stuff that we are going to be talking about, or that you'll be prepared for on the quiz next week, and the things that we talked about this week. And this idea that their programs convert from one programming language into another. Those are compilers, very common thing to write as programmers. Okay, the actual instructions. So there's this file markdowncompiler.py. Markdowncompiler.py. Again, you'll have to download that, and the way you'll do that, you will not copy and paste because then things won't work, but you'll click on it and right-click on the raw button and go to save as, save link as. And when you do that, there's some new things, some new ways to run Python that we're going to talk about. This first one right here, you've already seen before with the -m doc test and the -- verbose. That will help you actually running the, or verifying that your code works. But then there's some new techniques down here, and we're gonna spend the next few minutes in class talking about what this means. So I'm gonna switch over to VS Code now, and I have the markdowncompiler.py program opened up here at the top. And I made the terminal window just a little bit bigger so we can see a little more what's going on. And up here now, you see if I press this triangle button, then I'm going to get an error message that comes out. This is the error message. It starts with this usage keyword. Anytime you see something that says usage like this, it means that the command that got entered up here is not the entire command that it needs. And in this case, it needs what this markdown .py is doing is it's going to convert a markdown file into an HTML file. Inside of the project, so whoops, that's not it. It's back over here. Up at the top, we have a markdown file, this readme.md. The .md at the end stands for markdown. And so this is the file that you're going to be converting into HTML. This readme.md file is, again, exactly what the instructions are for this project. And so you're going to be running your markdown compiler on this file, and you'll get an output that looks like what these instructions look like. The question is, where is the markdown compiler file located? And in the repo, there's the project1 folder, and this is where the markdown compiler.py file is, along with all the instructions. Okay, so with this markdown.py file, we tried running it with the triangle button, but the triangle button didn't work. It gave us this usage error message. And what it's saying right here is that you have to add this -- input file command right here. So I'm going to press the up arrow button to get back to my previous command. It starts, very first thing somehow ends in Python 3. The second thing somehow ends in markdown compiler.py, but your commands will look a little bit different than mine. And then at the end here, I'm going to add the -- input _ file like this with an equal sign, and then the name of the file that I want to convert, which is in this case readme.md like this. Notice that there's no space between this equal sign right here, and that will be important. If you add a space, things will not work. It has to be input file space readme.md like this. I'm going to hit enter over here in a second, but I want everybody to pay attention. Everybody look at the screen. Make sure you're looking in this next 5 seconds, and look where my mouse cursor is over here on the left-hand side, where it says readme.md right here. You notice there is no readme.html file right now. It only says readme.md. We have no HTML file in this folder. But as soon as I hit enter right now, again, paying attention to right over here, I hit enter, and now this readme.html file was created. So again, when I just pressed the triangle button, I got this command right here, and it gave me this usage error down here. I pressed the up arrow to get back to the previous command that wasn't working, and then added this -- input file equals readme, not adding any spaces over here, just with the equal sign. And when I run it, it now creates that readme.html file like this. In order to view this file, I'm going to right-click on it and go to the copy path like that. Come back over to Firefox over here, open up a new tab, and paste that file right there. Hit enter, and you'll see something hideous looking like this. And in particular, you'll notice that there's no HTML actually anywhere in this file. This file only has the various markdown things. So we didn't cover exactly what these two things up here mean. But here you see the **, like that. That's what was bold. And then you can see that things are sort of divided up into paragraphs. The ** again. So this is literally just the raw exact output of the markdown file so far. We haven't done by default, the program doesn't actually do any processing converting things into HTML. That's what you're going to be implementing. Come back over to here. Let's take a look at the markdown compiler.py file. There's some more detailed instructions up here at the top. But then after this first big set of comments, there's a bunch of functions. Each function has a bunch of doc tests associated with it. Let's go. So here, the second one right here, compile italic star. So this one takes, we saw before that the star around something changes it into the I tag. And you're going to implement this function so that all of these doc tests right here pass, so that these doc tests pass. And when you do that, you'll see that something like this gets converted into something like this, so that all the stars get converted into the I's. For all of the markdown syntax that you'll be using, there's a separate function for each one of those markdown syntax. And so as you go through this one function at a time, once the doc tests pass, you'll be relatively confident that when you run it on the full file, it will correctly convert things from star into I, or whatever it is it's trying to convert. So I'm not going to open up exactly the contents of my solution.py up here, but if I, let's see, we'll Control C right here, so we're on a new line. I'll come over here just enough to press the triangle button. We'll see the solution gives the same problem over here. Press the up arrow again. So now we can see that the file over here ends in the solution. Press space, add the -- input file equals readme.md, and we'll see what the solution roughly should look like after running it on the readme file. So we have the readme.html over here. Come back over to Firefox, and since I've run it on the solution now, when I press refresh, it's going to reload it with the solution finished. And now you can see, okay, we have this like header thing up top. It's loading an image. All of our bold things are working. There's links over here that I can click. And now this actually looks like HTML somehow. Back over here. And one of the things that you'll notice about this is this still doesn't really look quite like GitHub because there's no style formatting associated with this. That the HTML is correct, but this does not have any CSS inside of it. So it's still a little bit ugly looking. If I come back to the instructions for the project right here, come down over here, what we've done so far is, so here it says also run the commands. We've talked about this first command right here, where we've added this -- input file equals readme.md. Now we're going to do that, but also with this -- add CSS. Back into VS Code. Press the up arrow to get back to my previous command. Press the space key down here. I'm going to add the -- add _ CSS right over here. And this is going to tell my Python script that not only are you going to do all that manipulation of the compiling of Markdown into HTML, but you're also going to add a script tag into the resulting HTML, and that will make it look pretty. Come back over here, look at the result, press F5, and now you can see that, okay, things are formatted a little bit more nicely like they are on GitHub. The header appears centered. There's this nice white space on the edges, and so on. So this is one of the reasons why we use Python programs to write HTML for us, is because it becomes then very easy to change how the output of that HTML looks, whether we want CSS or not, or other various features. All we have to do is run it with a different command down here. We don't actually have to do anything manually. It's all automated, and things look nice. Last thing I'll say before I pause for questions is that this is a really big file up here. Whoop, that's the solution. Here we go, the non-solution version. This is a really big file. Look at it, has 500 or so lines in it. You're responsible for editing the stuff, like all these individual functions. And then at the very bottom of this file, it says this final section does not need to be modified at all. This stuff does all of the converting the file into the actual web page, and so on. And so you don't have to understand how like any of this code right here works. It's just something that's given to you that's doing the actual like opening the file, reading the text, and then saving it. And this is a common thing in computer science. No matter what project you're working on, there will always be some sort of existing code that you're just not going to have time to like sit down and understand. Or maybe it's in a new language that you've never seen before, won't be able to do it, or it's using techniques you've never seen before, like in this case. And so part of the purpose of this assignment is to get you used to that there's this code, it already exists. You can look at it if you want, but it does magic. That's the right way to think about it, is that a magician made all of this do its thing, and you're just going to trust that it happens correctly. All that your job is to make sure that each of these individual functions successfully implements its test cases up here. And once you do that, the other code will glue that all together in the right way, making the output what it is. Question, yes.
So to be clear, so on Friday, we're going to work on the comment replying the issues, and then for the actual project, this is the project, or how it works?
Yeah, so question is about exactly what's the distinction between the lab and the project. The lab is to yes, that Markdown code. My guess is that vast majority of people will finish that relatively quickly, and then you can start the actual programming in the lab time, so you'll be able to ask questions about it. Or you could even complete the actual like lab part of the assignment before the lab class, and then only work on the programming during class, the part that'll be harder, where you might need to ask questions. But you're free to use that time how you want. But the stuff that's in this lab section right here, this will be due this coming Sunday. The stuff that's in the project file, this will be due. My recommendation is to try to complete it, get as much as you can completed this coming Sunday, but it's actually due the following Sunday. Yes?
When you're adding the like dash input line in your terminal, and you press enter, did you get like D quote? What is that?
So there's a question about, there's lots and lots of things that can go wrong about what happens down here. We'll have to look like one-on-one on exactly what the error message is. These error messages are going to be different from like Macs versus Windows or whatever version of Mac or Windows you might be using. And yeah, lots of ways that something like this could potentially go wrong. But definitely by the end of Friday, you want to make sure that you can at least run these and look at the results of the file, even if it's not like actually implementing any of this compilation from Markdown to HTML. It should still be able to generate the files, and you should be able to make sure that you can generate the files. Yeah, happy to look at that after class. Okay, one last thing, assignment, due date-ish, administrative, I guess. So that's the first part of your lab this Friday. The second part of your lab is so the reason like why Python is so popular is because people write these scripts like you're writing, and then they distribute them freely to everybody else in the world so that everybody can use them. And the part 2 of this is to start using some of those scripts that other people have written. Throughout the rest of this semester, there'll be another dozen or so of these scripts that we'll be using that other people have written. But this first one here is called YouTube DL, DL standing for download. And what this does is it downloads a YouTube video so you can play it on your own computer without a connection to the internet or without watching ads, however you want to watch a video. And so these instructions right here walk you through how to do that. And you'll see that if you don't run it correctly, you'll get error messages that look similar to the error message when you don't run your project correctly. It'll start with usage and then say other things that it wants you to do. And so you'll have to, this is the command to run YouTube download. You'll have to add various arguments, various things after YouTube download to get it to do what you want it to do. So the second part of the lab is to start getting you familiar with how to use other people's Python scripts like that as motivation for why we might want to make Python scripts the way we are making it for the project. And again, both of these parts due by this Sunday. Any questions on anything administrative, anything about the homeworks or project, lab, life? Question?
You can still like collaborate.
All the projects, all the labs, strongly encourage you to collaborate, and you'll get the 48-hour extension if you do so. And again, collaborate with people from the class, collaborate with CS majors at MUD, Pomona, collaborate with people at the QCL, do whatever is going to help you learn the material most efficiently. Okay. Then we have about 10 minutes left in class, and I'm going to switch back over to VS Code, and we're going to open up that notes.py file. That notes.py file is in the topic 4 folder. Here we go, notes.py. And we're going to see some of the techniques that you'll need to use on the project. So here I have a function called delete HTML, and you can see that there's a bunch of test cases down here. And these test cases look for HTML tags inside of the string and somehow try to remove those HTML tags. The sort of techniques that we'll be talking about here are the exact same techniques that you'll be using in your project file. Each one of those functions is going to basically be the exact same technique that we use here, with the slight modification that that it'll just be like different things that you're looking for. So let's get started. So the first thing that I'm going to do here, let's save this notes.py file down here. Let's get some blank lines just so I know where I'm looking when I run this. Up here at the top, I'm going to press this triangle button. I get the output right here. There is no output. That's to be expected when you press the triangle button on this file. I'm going to press the up arrow and the left button to go back between Python 3 and the name of the file over here on the right. Add my -m space doc test like that and hit enter. And we get all the information about the failing doc tests. So all I did was add the -m doc test right here so far so that we can see what is going on with these doc tests. And at this point, I have no code in this function. So as expected, all these functions, all these test cases are failing. Here I have an input text. That input text is going to be whatever this string is that's being passed to my delete HTML function. And I'm going to have to somehow process this text so that these things are removed. Well, we saw one way of doing that already with the replace function, doing something like text.replace. And the replace function, again, takes two parameters. The first parameter is the thing that you're looking for, and the second parameter is the thing that you are trying to remove. And so up here, if I'm trying to remove B tags, the bold, then I could be looking for the B tag like that. And then what I replace it with is the empty string, nothing. If I find all the B tags, replace them with nothing, then that would find this right here and replace it with nothing, giving me that thing over there. And if in order to make this work, I have to not just do the B tag, but the /B tag as well. Again, whatever you have inside the string, Python doesn't like try to understand it, try to interpret it in any way. It just looks for an exact match and replaces it. So this B up here, VS Code, we can see is helpfully highlighting this for me, matches this, but it does not match this over here. In order to match that over there, then I have to do text.replace and then /B like that, comma, with the empty string right there. And then I have no return value down here. So I always got to return something, return text like this, save this up top, come down here, and I'm going to rerun the test cases right here. Pressing the up arrow to get back to the command that contains the doc test, and I hit enter. And oh no, I see that I didn't actually make anything work. I still have 3 out of 3 failures. I'm going to go up, find the test case that corresponds to the B bold, and figure out what's going on. So over here, there's my scroll bar, scroll up to the top, and right here is my test case. It says delete HTML. This is B bold /bold. Expected, this is bold, but I got this is B bold /bold. And again, what's going on is that strings are, the key word here is they're immutable. You can't change the value of a string from inside a function. This replace function does not change the value of text. You'll have to have that down 100% pat for the quiz on next week. But whenever you have a function that appears to the right of a dot and there's the text, or whatever your string variable is over to the left, this function will not modify this over here. If you actually want to change what the contents of that variable are, then you must say something like text equals this. This doesn't change it. It returns a new value that, that contains the result. And now if I do text equals, now it's going to actually do the finding and doing the replacing. Save that, come down here, up arrow, rerun that. And now we have 2 out of 3 failures that that one particular test case right here is now in fact passing. So the key thing here to remember, and this is going to trip up everybody at some point in this class, is that when you have a string variable, and you have a function like replace is the most common one where this problem happens. When you replace on the string, it doesn't actually change that variable. It returns a copy of that variable with the modification. And so you have to say text equals that if you want to make the change actually happen. Any questions so far? Okay, so this passes the first test. Let's look at the next test. Text equals text dot replace, and then I can change the I like this to something empty. Text equals text dot replace, and the strong, whoops, not the I. We're still on the second test case with the I right here. We need the slash I, change that like that. Save that, come down here, up arrow, rerun it, and now 1 out of 3 test cases failing. So I'm making progress. But this is sort of like a fake progress because, like, I mean, in HTML, we saw that there's tons and tons of HTML tags. In this case, there's only 3 test cases, 3 different HTML tags in the test cases. But if I want my my function to actually be able to work with any arbitrary HTML, tag, then I can't use this replace function. For replace, I would have to copy and paste all like thousands of HTML tags that exist. And that's a huge, huge pain in the butt. Lots of copying and pasting, lots of room for manual errors, lots of room for me just to forget an HTML tag or something like that. And so this replace method it works for the test cases. This works for the test cases, but it's not very general. And so it's not the best solution. So I'm going to temporarily comment this out, and we'll work on a better solution. The idea of the better solution is we're going to use this accumulator pattern. So previously, when we saw the accumulator pattern, we only did it for lists. And the idea of using the accumulator pattern for lists was that we would always, anytime we somehow saw a list where we were trying to filter things out of it, trying to remove things from the list some way, that's when the key idea of you want to use the accumulator pattern. In this case, it's very similar, only it's not a list that we're trying to remove things from, it's a string that we're trying to remove things from. So this idea that there's something that we want to remove from a string, that means anytime you think about removing something from something else, think about the accumulator pattern. In this case, since it's a string that we're accumulating, we'll start with the empty string instead of starting from the empty list. Save that. The accumulator pattern will look something like I'll do C standing for character in text like this, and then we'll do something with C, We'll say accumulator plus equals C as like the most basic thing to start with. And then down here, instead of returning text, I'll go ahead and move this. I forgot to add this to the previous solution. Put that right there, return text. We'll do return accumulator like that. And so this is the basic outline of the accumulator pattern, just modified for text instead of lists. And now I also need some sort of if statement. And the idea of this if statement, I'll write it out in a comment as if we are inside of an HTML tag. That's what I want my if statement to somehow be like. And so I have to figure out how can I know if I'm inside of an HTML tag or not. I want to make sure that we don't go over time today. So we'll pause right here. I'll finish this up in the first 5 minutes of the actual lab session. I'll record that, and that'll get posted to YouTube as well. But this is a good stopping spot for us. And happy to stay after, answer any questions that people have about anything at all. Otherwise, I will see you all on Friday.